Hello, I'm Dr. Zia Tahir. This video tutorial is solution to problem 4 by 4.3 of Engineering Mechanics Statics 9th edition. The statement of the problem is determine the force in member BF of the loaded truss. So member force BF is required. Among two methods of truss analysis, method of joints and method of sections. So method of section is used here because only one member force is required. So steps to find member forces in method of section. The first step is plan a cut. And how is that? Choose an imaginary cut that passes through the target member. Target member is BF and with less 3 or less unknown member forces. So the possible cut here is here. Okay. So it is going to cut is going to pass to three members BC, BF, and then GF. Okay. And next one is step is to find support reactions if needed. So for this one, if I'm going to select left part, so the load is given, so there is no need of finding reaction. And if I'm going to select the right part of the cut section, so then two supports are there, so need to find supports reaction. So this problem can be solved, or this analysis can be performed without finding support reactions. This problem involves pulleys and cable, and these are the facts about pulleys and cable. The tension in the cable, the light and inextensible cable, is equal to the attached weight. So tension in the cable is equal to attached weight, or here is a load attached. So I'm going to assume that it is in pounds, and the tension on the both sides of pulley has the same magnitude and acts along the cable directed away from the pulley. So on both sides of the pulley, the tension is same, which is equal to the weight. And the third fact is the tension is uniform along any continuous length of cable. The tension along all that cable is same, and that is equal to L. So if at joint G, if the pulley is being considered, so the tension is same, which is equal to L. And then at joint F on the pulley, the tension is same on the both sides. So at the section, one member force, second member force, and third member force, they are unknown, and then the tension in the pulley on the cut section is equal to L. So the facts about the pulley and cable system, so they are used to solve this problem. Third step is choose a simpler side. So simpler side is left side with fewer loads, reactions, and fewer joints. So obviously that left side has only 3 joints, and draw its free body diagram. So I'm going to draw its free body diagram. So that is a free body diagram, and in the free body diagram show all external loads, reactions on this side, and represent the unknown cut member assuming tension. So there are 3 unknown cut members. One is BC, and I am going to assume that is in tension, that is BC. The other one is BF. So, and then the third one is FG. So these are 3 member forces, or I have assumed them in tension. And the other one, the known loads, external loads. So external loads are here is L. So because the tension in the pulley is the same, equal to the weight, and then the tension in a uniform is uniform along any continuous length of the cable. So then here is tension is equal to weight is equal to L. Okay. So that is the free body diagram. And next one, need to apply conditions of equilibrium to the cut part to find unknowns. So in this one, only unknown required is BF. So we don't have to go for all 3 unknowns, and we need to apply a strategy how we can find BF in a simple way. So to apply conditions of equilibrium, need to resolve inclined members into their components. So BF, so it has 2 components. One is acting vertically downward to the nearest, so that is BFY, and the other component of BF is there BFX. Okay, and to find BFX and BFY, need to find this angle here, which is theta, and then L, that has two component. So L, it has one component acting vertically upward, so that is LY, and the other component is acting vertically horizontal, so which is towards right, so that is LX. Now Ly and Lx, because the angle here is 10 degrees, so the angle on the other side will be 10 degree. So Lx, that will become equal to L cosine 10 degree, and Ly as L sine 10 degree. And to find angle here, so either I can find angle or I can use the sides. So here for BF, if I try to draw a right angle triangle, so in that right angle triangle, its height of the triangle is 7, and its base of that triangle is 8. So then I can use represent triangle here to show the direction of BF. So that is a triangle, and in that triangle its vertical length is 7, horizontal is 8, and then its diagonal using Pythagoras theorem is going to be 1 1 3. So the next one I can apply here, sigma f x equal to 0, sigma fy equal to 0, and sigma m equal to 0. So for method of section is usually recommended to use that sigma m about a point which has most unknown forces. So point B that has more unknown forces. But in this case, because BF is required only, so if I try to apply sigma Fy equal to 0, so in the vertical direction, there is only one unknown component BFY. The other two components are L and Ly. So if I just use sigma Fy here, if I just use sigma Fy here, so it is possible to find BF. Now so sigma Fy equal to 0, the first one is BFY, that is acting vertically downward, so it is going to be minus BFY, and then the load is going to act vertically downward, minus L, and then that Ly is going to act vertically upward, which is Ly or L sine theta, which is 10 degrees equal to 0. So then BFY, now using that triangle, and here using the fact Fy is equal to F times Y over Z. So BFY is minus BF times by Y vertical of that triangle. So 7 over 113 minus L plus L sine 10 degrees equal to 0, and then I can find simply BF into is equal to, now take onto the other side, so it will become L minus L sine 10 degrees, and then I can take that L as a common factor. So taking L as common factor, so it will be 1 minus sine 10, and then BF is being times with 7 over root 13. So it is going to the other side, so it will become 113 over 7. So now BF, after substituting all that in the calculator, so after substituting everything in the calculator, so the answer is 1.254. So 1.255 I'll write. So then BF is going to be minus 1.255 L. So now the next one is here, then the interpretation of the sign of unknown member. A positive value indicate tension, a negative value indicate compression. So because the answer is negative, so then BF is 1.255 L in compression. So that is the answer, 1.255 L in compression. So that is the solution. But if you have to use any other method like, sorry, any other condition of equilibrium like sigma m equal to 0 about any point, so then is required to find the radius of the pulley. So the radius of the pulley is required, and radius of pulley can be determined as, because half of the cable is equal to 4, and using that angle 10 degrees, it is possible to find the radius of the pulley. So that is whole complete solution for the problem 4 by 4 3. Thank you very much for watching.